Okay, good day. We're going to be working with the gravity, velocity, and acceleration equation, which we've already been introduced to. It says a basketball is thrown in the air from a height of 6 feet and initial velocity of 40 feet per second. Find the maximum height. Maximum anything, you draw a big parabola in the center, inverted parabola in the center of the paper. You make a coordinate point, and we're going to find the independent variable with opposite of b divided by 2 times a. That's how you're going to find the maximum. Now you need an equation. If they're asking you for maximum height, just put equals y, because what's causing the height to change is gravity and velocity together. So we're ready to lay it out. We don't need any parentheses, any of that. So this is gravity. Now that's the number that's not in the problem. It's negative 16. This is your rate, your acceleration rate, the per, that's 40. And right there's your starting height, and we know that that's 6. You got to know what those represent. So easy enough, AB. This is C, but I don't really need C when finding a maximum. So the opposite of B is negative 40, and then I take 2 times negative 16, and that's negative 32. Then I divide negative 40 by negative 32, and that's 1.25. So the variables I have are x and y. So now I substitute 1.25 into the equation for x to find y. So now that we have our x, I don't care if you're writing this part out. If you just want to go to your calculator, go ahead. Okay, now you're solving for y, which is easy because y is by itself. You just find what the other side of the equation would be equal to. Enter it just like I'm entering it. Okay, 31. So x is the time, seconds, and y is the feet in this equation. So maximum height was 31 feet. Okay, now I'm going to read the next problem. You're going to think it's the exact same, but it's not, because you're working with the same equation, but you're using it to find something different. A basketball is thrown in the air from a height of 6 feet with an initial velocity of 40 feet per second. Find the ball's height after 2 seconds. Now, you're not finding the maximum height. You're finding a height amount, but it's not the maximum. So if you are not finding the maximum, I would suggest you make a side box with feet and seconds as your units. Now define your variables. We already know that x is the seconds, y is the feet. Then per feet per second is going to be 40, at least the initial amount. Now don't make a table because this isn't a linear function, okay? Because when something goes up, it comes down. But you don't make it right in the center because you're not finding the top point, okay? Now, make a point there, read the last sentence, and write 2 seconds, and then a question mark with your answer, feet. So that's your answer to the problem. You're finding how many feet after 2 seconds. Now you lay out the gravity equation just down here. So we know gravity goes here, negative 16. The rate, the acceleration rate, the per goes here, and that's your 40. And this is where it started from, which is 6. Now you have the equation laid out. You got to decide what variable to put 2 seconds in for. Well, since seconds is x, 2 seconds goes into the equation for x. Good, I like putting numbers in for x because then I have to solve for y, but since y is by itself, it should be pretty easy. Y only has one answer because it's not to the second power, it's just the first, and it's by itself. So you just need to substitute that into your calculator, and that will tell us how many feet it is after 2 seconds. 22, okay? So 22 is your solution for y, it's 22 feet. It's going to be 22 feet after 2 seconds. Okay, third one. These come in rounds of 3. A basketball is thrown in the air from a height of 6 feet with an initial velocity of 40 feet per second. After how many seconds is the ball 45 feet in the air? First off, I need to cross out 45 and put 20. Now, the reason why I know right away I have to do this, and I made a mistake, okay? You don't do this on your own unless I tell you. But I can tell right away from reading it because I just had this problem where I found the maximum and it's 31 feet. Well, how the heck could it ever get to 45 feet if the maximum's 30? Okay, so I knew I made a mistake. 20 feet, okay? Now, you are not finding the maximum, okay? So you're going to want to make your units box with feet and seconds. Again, maximum, you just draw the inverted parabola in the center of the paper. But if I'm not finding a maximum, which I'm clearly not, okay, I'm going to make the parabola off to the side. So x is seconds, y is feet. Now, feet per second, the feet per second is 40 times x. Now, no table. So, goes up, comes down. Now, go on this side of the parabola. Look at the question. 20 feet's in the question. I put a question mark, and I look down here, seconds. Okay, now lay out the equation again. It's the same exact equation you laid out on the first two. You're just using it to find something different. So gravity, the rate, acceleration rate, 40. And the time, or the starting height is 6 once again. Now 20 feet has to go into this equation, and it goes in for y. It's a little bit more work to replace the y and to come back and solve for the x, but we can do it. If you listen, it's not going to be that much work. Equals 20. So, now I'm solving for x. Now, since it's x second, there's going to be two answers. Now, we have x second and x, but I'm not going to factor with the GCF-T and all that because 95% of the time the T doesn't work. You want to use the quadratic formula, okay? So before you use that, you have to get 0, minus 20, and that can go with your 6. Now you lay it out. So you've got negative 16, 40, and then 6 minus 20 is negative 14. So I'm not going to be drawing boxes. I'm going to go right to the quadratic formula. Opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So we have a, b, and c. Opposite of positive 40 is negative 40. B squared, it's going to be 40. Then A is negative 16. C is negative 14. Then the A is negative 16. So I lay it out. You know you got the negative 40 in front of the plus or minus. 2 times negative 16 is negative 32. Now I'm going to do my square root right here. Now today everybody needs to be doing it the same because we are on a story problem. Okay. $704. You are going to approximate if you want to go through that, fine, but you're wasting time because you get some pretty huge numbers here. On a story problem, I would just approximate it. I know in Mr. Larson's trade class on a story problem, he allows the approximate decimal. So 26.53. So I take negative 40, I add 26.53, click equals, then divide by negative 32, 0.42. Then I take negative 40 and subtract 26.53, click equals, divide by negative 32, that's 2.08. Now both these are answers, put them both over here, 0.42, 2.08. Now, the reason why there's 2 is this, okay? You don't need to write this down. We have the problem solved. If you have a negative over here, you don't put it. You only put positives over here, but they're both positives. Reason why is because we're finding when it's 20 feet. Well, if it starts at 6 feet, it's going to be 20 feet on the way up and it's going to be 20 feet on the way down, okay? So that's the time it gets to 20 on the way up. That's the time it gets to 20 feet on the way down, okay? Now, you're not always going to get two positives. I think on the one I come to again, you're not going to get that, okay? New problem. Football is punted from a height of 3 feet above the ground with an initial velocity of 45 feet per second. Find the football's maximum height. So again, you're calculating a maximum. So I know right away that I have a coordinate and I apply the opposite of B divided by 2 times A. So again, we're going to let the height represented by Y, okay? And then what's causing the height to change is the gravity combined with the acceleration. So that's your blank x, that's your negative 16x second plus the velocity x. So negative 16, that's your gravity. Then the per, that'd be 45. Then 3. A, B. Not that I really need C, but I'll label it. So the opposite of B is negative 45. X and Y are your variables. X is your seconds, Y is your feet. Okay, I don't care if you put those labels, but that's what they represent. 2 times negative 16 is negative 32. Just round that to 1.41, please. If you want to go second PRB, Ken, I don't care. 1 and 13 30-seconds. I'm just going to go 1.41. So it's going to take 1.41 seconds to get to the maximum height. Now to find the actual maximum height, we substitute 1.41 in for the x. Okay, and I just have to solve for y, which is easy to do since it's already by itself. To the second plus 45, 1.41 plus 3, 34.64. Okay, so 34.64 feet is the answer. Can't get any higher than that. Okay, next one. Football's punted from a height of 3 feet above the ground with an initial velocity of 45 feet per second. After how many seconds is the ball 25 feet in the air? Okay. Actually, hold on. I want you to cross out 25 feet, put 0 feet, please. Okay, 0 feet, because I said so. Okay, so again, we're not finding the maximum height. We're not finding the maximum for anything, okay? So I start with my units box and define the feet and the seconds. X is seconds, Y is feet. We're finding seconds. We're going to be solving for X here. Then the feet per second is 45. So now it's still a parabola. That doesn't change, but I'm not finding the maximum. So I make it on the side, okay? And I'm going to put 0 feet right there. I don't care where you put it. 0 feet, question mark, seconds. Find how many seconds it takes down to get to 0 feet. Okay, so blank x second plus blank x plus blank equals y. Okay, so you got negative 16 for your gravity. This is your per, that's going to be 45. And this is your starting amount, which is going to be 3. Okay, now where would we put 0? 0 has to go into the equation. 0 feet, and it's going to go in for my y. So we are replacing our y. So I guess if I'm replacing my y, I have to solve for the x. Now, x has 2 solutions in the equation. Maybe not in the overall problem, but in the equation it has 2 solutions. Okay, you got x second and x, but I don't really care to factor these because 95 times out of 100 I can't find the t-chart. It's prime, so you are using the quadratic formula. Okay, so opposite of b plus or minus the square root b squared minus 4ac over 2a over 2a. Opposite of b, negative 45. b is 45 to the second. A is negative 16, C is 3, and A is negative 16, okay? Plus minus, you got your negative 45. 2 times negative 16 is negative 32. Now I'm going to set up the square right there. Okay, so 45 to the second minus 4, negative 16, and 3. Okay, 2,217. Now, some of you yesterday on a story problem, I would just approximate that as a decimal. Okay, you want to waste time going through that, fine. I'm not going to freak out, but 47.09. Then we solve it. So negative 45 plus 47.09, click equals, then divide by negative 32. So I got negative 0.07 when you round to the nearest hundredth. Divide by negative 32, 2.88. Now don't bring the negative over. The only answer is 2.88 seconds. Now here's why there's only one on this one. You got to remember that this started at 3 feet, so it's not going to be 0 feet on the way up, only on the way down. Okay? So that's the reason for that. Okay, my last problem. A football is punted from a height of 3 feet above the ground with an initial velocity of 45 feet per second. How high is the ball after 1 second? So again, you're not finding the maximum. It's still the gravity equation. You're just not finding, so you define your feet and your seconds. Seconds is x, feet is y. So per, feet per second. 45 times x. Now, the table's worthless because it's not a linear equation. When you punt a football, it kind of goes up and comes down. Okay. Now, mark a point here and just put 1 second. And question mark, feet. Okay. So, lay it out. So you got your gravity, negative 16. You got your per, 45. You got where it started from, which is 3. Okay. And this is going to be kind of an easy problem because 1 second goes in for the x variable, the independent variable. So I just replace both the x's with 1. And then y is easy to solve for. I mean, it only has one answer because it's to the first power. Okay. Now, if y had 2 answers, that's a problem because it's not a function. Okay. Y should only have 1 value. You can have multiple x answers, but no repeated y answers. 32. Because you remember, now some of you took me for Algebra 1. If you remember, when you have a bunch of x, y points, the x can repeat itself, but the y can't. Okay, so 32 feet.